Good morning, students. Myself, Vijay Shankar from ECE department, Chipdol Engineering College. Today, we are going to discuss about another topic in the electromagnetic wave characteristics. That is uniform plane wave in free space. Okay. In yesterday's class, we derived the waveform equations. General equations for E bar, D bar, H bar, and B bar. See, for the H bar, the wave equation for the H bar, here there is a sigma into del cross E bar plus epsilon into dou by dou t of del cross E bar. So del cross E bar is replaced with the minus mu dou by dou H bar by dou t. So here already the dou by dou t is already there. There's some mistake in yesterday's class. Here there is another dou by dou t. Okay, please note down, my dear student, this one. There is a printing mistake here. Del cross H bar is equal to sigma into del cross E bar plus epsilon into dou by dou t of del cross E bar. So in this 13th equation, you can replace the del cross E bar is equal to minus mu dou H bar by dou t. So del cross H bar is equal to sigma into minus mu dou H bar by dou t as of del cross H bar, and the epsilon is here, and dou by dou t is not there. So del cross H bar is equal to minus mu dou H bar by dou t. Then here it is becomes of del square by, not the del square, dou square H bar by dou t square. After that, it is a minus mu into sigma dou H bar by dou t and minus mu epsilon dou square H bar by dou t square. Got it, my dear students? There is some mistake here. Then we'll get here dou square H bar by dou t square. Here also the mistake is there. Dou t square. Got it? Please note down that. We go for the next topic, uniform plane wave in free space. In yesterday's class, we discussed few amount for this. Again, I will start to derive the expressions of uniform plane wave in free space. According to Faraday's law, so not the Faraday's law, modified Ampere circuit law, del cross H bar is equal to J bar plus dou d bar by dou t. J bar plus dou d bar by dou t. J bar means conduction current density JC. That JC is equal to sigma into E bar. Because it is a free space and nothing but a dielectric, sigma by the omega epsilon is very much less than the 1. It's a perfect dielectric. Sigma is very much less than the omega epsilon. Okay, so J bar is equal to sigma into E bar. Got it, my dear students? Sigma, the conductivity is very, very less here. In the dielectric, the conductivity is very less. So the sigma is equal to 0. The J bar is equal to 0. Then it becomes it's a perfect dielectric. J bar is equal to 0. The equation becomes del cross H bar is equal to dou d bar by dou t. So before that, you have to know in electromagnetic wave traveling in free space, consider that electric field E bar is in the x direction. Is in x direction, means it is a EX bar, and magnetic field is in y direction, so HY bar. In this, the uniform plane wave in free space, both the fields will not vary with respect to the will not vary with respect to x and the y. With respect to the y, we can apply the derivative with respect to x or the derivative with respect to y for each. Both the fields, electric field and the magnetic field, is not varying, means zero. It varies with respect to the z only. And another condition here, they will also change with the time as the wave propagates in a free space. That means here, when the ex is in the x direction, means ey and the ez is equal to 0. This is also the other condition. If h is in the y direction, magnetic field is in the y direction, means hx and hz is also the 0. hx and hz is equal to 0. So remember these conditions. Then substitute the d bar as the coordinates, rectangular coordinate system. The rectangular coordinate system dx ax bar plus dy ay bar plus dz into az bar. Now you can find the del cross h bar with some conditions we have. Del cross h bar is equal to, listen carefully here, del cross h bar is equal to ax bar, ay bar and az bar, dou by dou x, dou by dou y, dou by dou z. And here I'm taking the h terms, hx, hy and the hz. Okay. So del functions is a dou by dou x, dou by dou y and dou by dou z, and h is a hx, hy and hz. Write the first equation. The first equation for the ax bar means you can see the ax bar, these four, dou by dou y into hz minus dou by dou z into hy, all multiplied with ax bar. Okay, my dear student, AD minus BC like this. This is the first equation, first term here. Dou hz by dou y minus dou hy by dou z into ax bar. For the second function, let me take the plus ay means dou by dou x into hz minus dou by dou z into hx, all multiply with the minus ay bar. So minus you can multiply, it becomes a plus, and this term is a minus. Okay, so dou by dou z of hx minus dou hz by dou x into ay bar. Okay, can multiply the minus for the second term, and the last term az bar. Take these four. Dou by dou x of hy minus dou by dou y into hx, all multiply with the az bar. Okay, dou hy by dou x minus dou hx by dou y into az bar. The third term we got, and is equal to dou by dou t of dx ax bar plus dy ay bar plus dz az bar. And here, as h bar is in y direction, hx hz is equal to 0. Hx, wherever the hx is there, that is a 0. Hx is a 0. And another hx here, the hx is a 0. And hz is also 0. Hz is 0. Hz is 0. And we have only the two terms remaining, that is hy. In this also, the another condition we have, that another condition is it is not varying with respect to the x. Either it's a h or e, not varying with respect to the x. So dou by dou x is there, not varying with respect to x means the term dou hy and dou x is also get cancelled. Only the remaining is dou hy by dou z into ax bar. This is only one term. We have minus dou by dou z hy into ax bar in the left hand side. By applying the conditions hx and hz is equal to 0, and magnetic field and the electric field not varying with respect to the x, it varying with respect to the z only. So dou hy by dou z into ax bar is equal to dou by dou t of dx ax bar, dy ay bar, and dz az bar. Understood, my dear students? Now, comparing only the ax terms, LHS and RHS, remove the y terms and the z terms. We have dou hy by dou z is equal to dou dx by dou t. And dx is replaced with the epsilon into e bar. The equation becomes dou hy by dou z minus z is equal to epsilon into dou ex by dou t. Otherwise, dou hy by dou z is equal to minus epsilon into dou ex by the dou t. Means h is in the y direction, e is in the x direction. With respect to the z only, we have the values. Okay, equation 1. So we derive this equation from the Ampere circuit law, modified Ampere circuit law. And the next equation from the Faraday's law, assume that is a del class E bar is equal to minus dou by dou t of d bar. This is the equation, my dear students. Now the del class E bar is equal to, again you can take the ax bar, ay bar, az bar, and dou by dou x, dou by dou y, and dou by dou z. And here you can take the e, not the h, sorry, ex, ey, and ez. Okay, I can find the first term, ax bar coefficient is for these four functions, dou by dou y into ez minus dou by dou z of ey. Okay, see the same function we got here, the first term, dou by dou z ey minus dou ez by dou y. Okay, why it is a minus means already we have that is a ax bar. You can take here the plus dou ez only. Sorry, here dou by dou y into ez only, and minus dou ez by dou y. Let us take this a minus term and this a plus term, my dear students. First of all, then minus ay bar into the terms here, dou by dou x into ez bar ez minus dou by dou z into ex. Now multiply the minus here, it becomes a plus, and here the minus and the plus. So see the second term here, dou by dou z of ex by dou z minus dou by dou x of ez. Second term is okay. And the third term, az bar is multiplied the coefficient. These four terms, dou by dou x of ey minus dou by dou y of ex. Got it, my dear students? Into a bar. And here see dou ex by dou y minus dou ey by dou x. Here also it is a plus and this one you can keep the minus into AZ bar. That is equal to minus dou by dou T of B bar, Bx AX bar, By AY bar, Bz AZ bar. The first condition you can apply here because the E value, E is in the x direction, E is in the x direction. So EY and EZ, EY, EZ is equal to 0. So wherever the EY is there, that is a 0. EZ is also 0. EY is a 0 and EZ is also 0. Got it, my dear students? And again, the magnetic field and the electric field not varying with respect to the Y. So you get the dou by Y is there, dou Y is there. It is not varying with respect to the Y. It varying only with respect to the Z only. Dou by dou Z of EX. Okay. In the left hand side, it remains dou by dou Z of EX into AY bar. Okay, my dear students, AY bar. So now you can compare here AY bar only. Understood? Here it is a plus or minus. If it is a wrong also, they are get cancelled all the terms. Only we have the dou EZ by dou X only. Okay. So now, in the right hand side, comparing the only the term By term here minus dou by dou T of By and dou Ex by dou Z. The both are in the Y directions. Got it? So finally we got dou Ex by dou Z is equal to minus dou by dou T of By. Now the B term we can replace with the H term with the relation of B bar is equal to mu into H bar. So dou Ex by the dou Z. See here also with respect to the Z only the term we have minus mu into dou Hy by dou T. Got it, my student? And now rewrite this function as dou Hy by dou T is equal to minus 1 by mu into dou Ex by dou Z. It's the second equation. It's the second equation. Okay. Understood? By Faraday's law, we derive the function, and by using the Ampere's modified Ampere circuit law, we derive the equation. We got one is dou by dou Hy by dou T is equal to minus 1 by mu into dou Ex by dou Z. Got it, my dear friends? Then here, both sides we can take it as both sides differentiating the equation 1. Let what is the equation 1 here with respect to the T? Equation 1 is this is the equation 2. Equation 1 is dou Hy by dou Z, my dear students. Dou Z is equal to minus epsilon into dou Ex by dou T. This is it. This is the equation 1. Okay, my dear students. We got here dou Hy by dou T. So multiply or differentiation on both sides with respect to the T. So now I am taking the dou by dou T of dou Hy by dou Z is equal to minus epsilon into here dou by dou T is already there, so it becomes of dou square by dou T square into Ex. Okay, now it becomes of dou square Hy by dou T and the dou Z. With respect to the T and with respect to the Z is equal to minus epsilon into dou square by dou T square into EX. Got it, my dear students? Remember this equation. And similarly, to equate the two functions, here we can derive or differentiation on both sides with the dou by dou z of dou hy by the dou t is equal to minus 1 by mu into, already here the dou z is there, so it becomes of dou square ex by dou z square. Okay, so now we can observe here these two equations are the same. In the left hand side, dou square hy by dou t dou z is equal to minus epsilon dou square by dou t square ex, and here minus 1 by mu into dou square ex by dou z square. Here it is a t square and here the z square minus. Okay. Now, after comparing these two equations, you can write as minus epsilon into dou square by dou t square ex is equal to, and this one minus 1 by mu into dou square ex by dou z square. Okay. And both sides is a minus is there, it becomes a plus. And again, they rewrite the function as dou square ex by dou t square is equal to, now you can bring the epsilon in the right hand side, becomes of mu epsilon into dou square ex by dou z square. Okay. Now this equation is again comparing with the dou square ex by dou t square is equal to 1 by v square into dou square ex by dou z square, my dear students. So after the comparing of these two functions, see what is a 1 by v square is equal to 1 by v square is equal to 1 by, not 1 by b square is equal, sorry. See, it is not the 1 by v square, my dear students, so b square is equal. Okay. V square is equal. So v square is equal to v square is equal to 1 by mu epsilon, and v is equal to 1 by the under root of mu epsilon. The velocity of the propagation v is equal to, not the potential, my dear students, it is the velocity of propagation or propagation velocity v is equal to 1 by under root of mu epsilon. And mu is equal to 4.10 to the power of minus 7 and epsilon is equal to 8.854 to the power of minus 12. It is approximately equal to 120 pi, I think. Okay, my dear students. Now you can see whether these equations will get the same or not. V is equal to, see here the V is equal to, we got V is equal to under root of 1 by under root of mu epsilon. Okay, dou square ex by dou t square, dou square ex by dou t square is equal to 1 by mu epsilon dou square ex by dou z square. So according to the results in the physics, V is equal to the velocity of propagation is also called a wave velocity. For the free space, it is denoted by c and is equal, the value is 3 into 10 to the power of 8 meters per second. Got it, my dear students? The velocity of propagation, also called wave velocity, v is equal to 1 by under root of mu epsilon, where the mu is equal to, we can find out the equation pi into 10 to the power of minus 7 and epsilon is equal to 8.854 into 10 to the power of minus 12. Take under root of these two equations, which is approximately equal to the 3 into 10 to the power of 8 meters per second. Okay. The uniform plane wave in a free space, we got a velocity of propagation or wave velocity. Dou square Ex by dou T square is equal to V square into dou square Ex by dou Z square. The above equation is a wave equation and it is a differential equation of a second order. Solving this mathematically, the solution is given by. Means you can take the Ex, means electric field in the X direction with the cosine wave, having a positive amplitude and the negative amplitude. Let us assume Ex is equal to Em plus cos omega T minus beta Z plus Em minus cos omega T plus beta Z volts per meter. The above equation 7 is a sinusoidal function consisting of two components of the electric field. One is in the forward direction, another one is a backward direction. The wave consists of one component of field traveling in positive Z direction, having the amplitude is Em plus, while other component having the Em minus traveling in the negative Z direction. Okay. Now I'm taking here the omega is a common term. Ex is equal to Em plus cos omega. Omega is a common T minus beta omega Z plus Em minus cos omega. You take the common T plus beta omega, beta by omega into Z. Two partial differentiations of equation 8. Two partial differentiations. You can apply the partial differentiation. Dou Ex by dou T, dou Ex by dou Z square. Z means here the Z is there. So Em plus cos omega T minus beta omega into Z and the beta omega. Let us take it is a Ex. One time you can apply the dou by. First derivative, you can apply the first derivative, my dear students, for this Ex. Dou by Ex is equal to Em plus, okay, the cos omega T minus beta omega into Z. You can apply that is a sine term. And with respect to Z, we are applying here. Sorry, it is not dou Ex by the dou Z. With respect to the Z, we are applying. So the term is here beta omega Z, not the beta by omega Z coefficient. Okay, one time you will get the minus beta omega. Similarly, this is a Em plus. For the second term also, Em plus, Em minus, again the cos function, you can get the derivative with respect to the Z, and the Z coefficient is a beta by the omega. Got it, my dear friends? Then dou square Ex by dou Z square. The second derivative now we can apply the dou by dou Z square into Ex is equal to, for the same function, whatever we got here, this sine function, and here the sine, cosine becomes a sine, and the cosine becomes a sine here. Again, you can apply the derivative. Em plus, this is a coefficient. Sine becomes again the cos, and the Z coefficient is a minus beta omega. Already the minus beta omega is a minus into minus is a plus beta square by omega square. Okay, my dear students. The same function again will get cos. Cos one time will get the sine. Second derivative, it becomes again the cos of. Got it? Plus Em minus. For the first derivative, the cosine becomes a sine, and the second derivative sine becomes a cosine. And For the second derivative, the z coefficient is a beta omega. Beta by omega is there. Already the beta omega is first derivative. For the second derivative also, you get the beta by omega, the square. So we got the dou square by dou z square Ex is equal to Em plus cos omega t minus beta omega into z, beta square omega square, and here also beta square omega square, beta by omega square. Take the common as beta square by the omega square. Got it, my students? And again, we can apply here with respect to the t. With respect to the t. So first time we'll get this cosine is a sine. Second time we'll get the sine is a cosine. The same function we'll get. The same function we'll get for the dou square Ex by the dou t square also. Okay, now we can multiply these two as a beta square by omega square. The term will get the beta square by the omega square. Got it, my dear students? So we already compared this equation with v square. You see, dou square Ex by the dou z square, dou square Ex by dou z square, and dou square Ex by dou t square. Okay. From this equation, you can write this dou square Ex by dou z square is equal to, now I am writing this as 1 by v square. 1 by v square into dou square Ex by the dou z t square. Now compare the equation now with this equation. See, in the left hand side, both sides is dou square Ex by dou z square, dou square Ex by dou z square only. In the right hand side also dou square Ex by dou t square, but 1 by v square is equal to 1 by v square is equal to beta square by omega square, and v square is equal to omega square by the beta square, and v is equal to omega by beta. Another equation. Now the v is equal to the wave velocity of propagation, or the wave velocity is equal to omega by beta. You know, this is an equation we already derived in the one of the chapter. Okay. The v is equal to, now we got in terms of the constants under root of mu epsilon, and now here it is omega is equal to omega by beta. What is the omega? 2 pi f. What is the beta in terms of the lambda? 2 pi by lambda. 2 pi get cancelled. The another relation is there for the v. V is equal to f lambda. So v is equal to f lambda. So we got the three equations for the v. V is equal to 1 by under root of mu epsilon. And another one is a v is equal to f lambda. After substituting the v is equal to omega is a 2 pi f, and the beta is equal to 2 pi by lambda. 2 pi get cancelled, lambda will get in the numerator. V is equal to f lambda. Three equations we got for the wave velocity or propagation velocity. V is equal to 1 by under root of mu epsilon. V is equal to f lambda. V is equal to omega by beta. Got it, my students? And similar way, we can find out in terms of the dou hy by dou t also. Dou hy by dou t. Hy is equal to hm plus cos omega t minus beta z, and hm minus is cos omega t beta z also. As we get in the Ex is equal. Ex is equal to, with the amplitudes of positive direction and the negative direction, the cosine. Similarly, for the magnetic field also, hm plus positive direction and the negative direction of hm plus and h of minus. Okay. Now, this equation is similar to the seventh equation representing the two components of magnetic field. One is in the forward direction while another is in the backward direction. Okay. it is clear that when we assume X component for E bar, it results in Y component for H bar. See here, for X bar, X component is the EX and Y is the HY component. Both E bar and H bar in the time phase and both are perpendicular to each other. When the X is in the E is in the X direction, H is in the Y direction, means both are in the perpendicular directions. Both these fields lie in a plane which is perpendicular to the direction of wave propagation. Thus, E bar and H bar together form a TEM, transverse electromagnetic wave, with one forward traveling wave in a positive Z direction with velocity is W by beta, and another backward traveling wave in the negative Z direction with the same velocity. Okay, the E bar and H bar together form a transverse electromagnetic wave, TEM wave. One is forward traveling wave in a positive Z direction with a velocity, the same velocity. Another is a backward traveling wave in the negative Z direction with the same velocity. Either it is in the backward or the frontward. Okay. Thus, E bar and H bar are only the functions of the direction of the travel and the time. Okay. In general, when any wave propagates in the medium, it gets attenuated. The amplitude of the signal reduces. This represents the attenuation constant alpha in the propagation constant P is equal to alpha plus I into beta, the propagation constant, where alpha is attenuation, beta is the phase constant. If any wave is propagated in a media that gets it attenuated, means the amplitude is some reduces. This represents the attenuation constant alpha. It measures in Napier per meter, but practically it is expressed in decibels. The conversation between the basic unit Napier and the decibel is given by 1 Napier is equal to 8.686 decibels. It is also observed that when the wave propagates, the phase change also takes place, beta. Such a phase change is expressed by the phase beta. It represents in the radian per meter. Beta is equal to, phase constant beta is equal to radian per meter. Okay. So the gamma is equal to, or the P is equal to. The P we are considering the transmission lines, my dear students. Now, the propagation constant in the electromagnetic wave characteristics, gamma is equal to alpha plus I beta. The propagation constant, now we can represent it as a gamma. Gamma is equal to alpha plus I beta. The ratio of amplitudes of E bar to the H bar, E bar to the H bar means E M plus by HM plus is equal to minus EM minus by the HM minus. Is nothing but the eta, intrinsic impedance. The ratio of amplitudes of E bar to H bar, EM plus or HM plus of the waves in either direction is called intrinsic impedance of the material in which the wave is traveling. It is denoted by the eta. It is denoted by the eta. Eta is equal to EM plus by HM plus is equal to minus EM minus by HM minus. Okay. What is the EM plus HM minus means? When we compare here the omega mu by EM plus and the HM minus, is here. EM minus the HM minus or the EM plus by the HM plus omega mu by the beta. Omega mu by the beta value. HM plus, the coefficient of HM plus here. The beta is beta, the Z, here the beta by the omega is there in the coefficient. See here. Beta by the omega, HY is equal. Okay. So omega mu by the beta, omega by beta is a V. And this is a omega by beta is a V into mu. What is a V is equal to 1 by under root of mu epsilon. And eta is equal to under root of mu by epsilon. Okay, my dear students. So eta is equal to the ratio between of EM plus by HM plus. That value is omega mu by the beta. What is the omega by beta is the V. V into mu. What is a V in terms of mu and epsilon? Mu epsilon into mu. And here the mu is get cancelled with the root mu. So eta is equal to under root of mu by epsilon. Again, the mu you can substitute as a 4 pi into 10 to the power of minus 7 and by 8.854 into 10 to the power of minus 12. It is, I think it is, this is equal to the 120 pi r 370 ohms or 3 something. Okay, let us see that also. 120 pi and 377 ohms minus by taking the values of mu naught and the epsilon naught in the free space. Because this is a uniform plane wave for the free space only. The eta is equal to under root of mu naught by the epsilon. And V is equal to C. So 1 by the under root of mu naught into epsilon naught approximately equal to the 3 into 10 to the power of 8 meters per second. I already told the lambda is equal to 2 pi by the beta. And the relation of V is again the F into lambda. The velocity V is equal to F lambda. Okay. So in this uniform plane wave, we derive the velocity is equal to omega by beta. That velocity is equal to 1 by under root of mu epsilon. And same that velocity is equal to F lambda. And another one is the eta is there. That eta is the ratio between of EM plus by the HM plus. That is equal to minus EM minus by HM minus. The value is omega mu by the beta. Means B into mu or otherwise under root of mu by epsilon, or otherwise it is a value of 120 pi ohms or 377 approximately ohms. Got it, my dear students? Okay, and that V, how we got the F lambda? I already wrote 2 pi F into beta. Beta is a 2 pi by lambda, not the 2 pi by beta. Okay, lambda is beta is equal to 2 pi by the lambda. So V is equal to F lambda. Got it? These all the parameters we got in the uniform plane wave for in free space. Got it, my dear students? It's a very, very important.